Hi everyone. So I'm going to be continuing with exploring conditional probability using a Venn diagram approach. With June 2016 question 4, S1 EdXL as our canvas against which we're going to paint. So we're told that a Venn diagram shows the probabilities of our customer bookings at Harris Hotel, and if R represents the event that the customer books a room, B represents the event that the customer books breakfast, D represents the event that the customer books dinner, and we're told that B and D are independent. And we're asked to write down the probability that a customer books breakfast but does not book a room. So let's look at the Venn diagram. So if we're to mathematize this information, they're asking what's the probability of B intersecting with R complement. Now, if we observe, notice that B is a subset of R. So B is entirely enclosed in R. So that means that B does not intersect with R complement. This is equal to 0. Therefore, there's no way that you can book breakfast without booking a room. So let's look at part B. We need to solve for U and T. And as long as you see two unknowns, we know that we need to set up two equations in order to generate the required information. So the first bit of information is going to be gotten by using the fact that B and D are independent. So recall that independence means that the union of the intersection rather of B and D is equal to the product of the probability of B and D. So if we look at our diagram, B is this part right here that intersects with D. So 0.27 is equal to the probability of B. So the intersection of B rather is this part. Probability of B is 0.6. And the probability of D is going to be 0.27 plus 0.15 plus T. So that's 0.42 plus T. So if we were to rearrange for T, T will be 0.27 divided by 0.6 minus 0.42. If we're to do that in a single step. And then solving 0.27 divided by 0.6 minus 0.42. So that tells us that T is equal to 0.03. Okay, so given that T is equal to 0.03, we can now add all of these terms together and get to 1. So we know that all of the probabilities add up to 1. So 0.33 plus 0.27 plus 0.15 plus 0.03 plus U equals 1. Everything outside is 0. So 0.33 plus 0.27 plus 0.15 plus 0.03, that gives us 0.78. So U is equal to 1 minus 0.78, which is 0.22. All right, so we can note that U is equal to 0.22 and T is equal to 0.03. So we're going to use that information to answer the remaining half of the question. So stick around for the remaining